Now in this lecture we are going to see the vector operations. First one, the multiplication. The multiplication of a scalar vector by scalar. Uh, so multiplying the vector by scalar, you may get the new physical quantity, new vector quantity. So if you multiply the vector p, let us take an example. Vector p is one vector, and if you multiply this vector by this scalar quantity s, then you may get new physical quantity, new vector quantity, say q, vector q, which is other vector. So the vector q will be the vector whose direction is same. Now you can say that this is the q has the direction as that of the p. You can take the one more example. According to the Newton's second law, you can write vector f is equal to m into a. So vector a is called the acceleration vector, and mass is the scalar quantity. If you multiply this, you may get the vector quantity f, force. Now this force has a direction as equal as the acceleration, direction of acceleration. Okay, so you may get new physical quantity. Now the addition and subtractions of the vectors, the addition or the subtraction of two vectors, two or more vectors of the same type, that is describing the same physical quantity, gives rise to a single vector, such that the effect of this single vector is the same as the net effect of the vector which have been added or subtracted. First of all, keep it into mind that the addition or the multiplication operation requires same vector. That means if you have to add two quantities, say velocity v1 and v2, that means both quantities are same type, both vectors are of same type, but you cannot add the quantity. One will be velocity and other will be force. Both vectors are different, then you cannot add these two things. So you require same quantity for addition or subtraction. Now when you add or subtract these two quantities, you may get the third vector quantity, and that vector will be single vector. That means v1 plus v2, vector v1 plus vector v2 gives you vector v. So this vector v is the single vector, and the effect of this single vector is the same as the net effect of these two, means the addition of these two vectors, or if the subtraction will be there, then the effect should be subtraction. But the net effect on this vector will be dependent on the operation on this of this. So added or subtracted, should be added or subtracted. So that is very, very important. It is important to understand that only vectors of same type, only vectors of the same type should be added or subtracted. In case of multiplication, the matter is different. Okay, so you have to add the same type vectors of the same type. That means you can add force, different forces, you can add different velocities. Okay, so the quantities must be of the same type. it is easy to find the addition of two vectors. So added how you can be added two vectors? See, if you have vector AB and vector BC, then vector AB plus vector BC then vector AB plus vector BC is equal to vector AC. Okay, so but AB and BC must be of the same type. Now both having different magnitude, but type must be same. So if individual vectors are parallel, the magnitude of the resultant is the addition of individual magnitudes. So the resultant must be the addition of magnitudes, but the vectors must be parallel to each other. And the direction of the vector of the resultant is the same as the direction of the individual vector. So both have the same direction. All this, so the answer and both vectors have the same direction. However, if the individual vectors are opposite or anti-parallel, individual vectors are opposite or anti-parallel. Anti-parallel means the the direction. If one vector, say vector A, having this direction, then other vectors B having this direction. So the heads of the both vectors are opposite to each other, then those vectors are called as anti-parallel. Then the subtraction will be taken place. The magnitude of their resultant is different. So how they can be added? So instead of addition there will be subtraction, just like that. So vector AC is equal to, so this sign is of the magnitude, sign of the magnitude is vector AB minus vector BC. Okay, so this happened to anti-parallel vectors. Now for vector addition there is a law, say triangles, some different laws are there. Here is a law, say triangle law. So what does that law say? When two vectors of the same when two vectors of a given type do not act in the same or opposite direction, the resultant can be determined by using the triangle law.